Okay, ladies and gentlemen, welcome back to Math 20-3, Chapter 1, Section 5, Rate of Change, Part 3. So, who makes more money? Now, last thing I need you to do is find the slope of the line segments that represent grants and seeds paid for hours worked. Now, what can you conclude from these values? So, I need you to find segments that represent grants and seeds paid. What can you conclude from these values? Well, we have to find the slope. Now, grant, let's go back here. This graph. Here's a nice one. Grant's purple. So we're looking for rise over run. I'm arbitrarily going to choose any 2 points on the straight line. I'm going to choose this one and this one because I can. So I'm going to rise and run. So here we're going from 40 to 80. So my rise is what? 80 minus 40, which is 40. And my run, 2 hours to 4 hours, is 2 hours. So, grant, that's a rise of $40 for 2 hours, which is, I believe, $20 per hour is rate of pay. Now, Steve, remember, is $16 an hour plus. Steve makes $16 an hour plus $20 gas amount. So I want to bet that Steve's slope is 16. Now, trouble reading this off the graph, but let's give it a try. Okay. So, choose 2 points, this one and this one. Now, it's a little hard. That's 20, 30, I don't know. Not quite, it's a little less than 120, a little more than 140. Here's the problem, reading points off the graph sucks. So that one kind of sucks. I will point out a nicer one right here. He starts at 20. Now, is there another point that's sort of kind of close? Oh, this one. So he starts, that rise is like from 20 to almost 120, like 118. And the run's like 6 hours. So here's the problem. Reading the exact number on the graph sucks sometimes. So 118 is 6. Maybe close. 18 over 6. And grab Mr. Calculator. Did I get it right? 6. 19. So I'm close. Yeah. That does suck. Wait a minute. I did make a boo-boo there, didn't I? I can hear you yelling at me. As you should, 20 to 120. I said, how about 118? So that's 98, not 108. Oh, Mr. Sutton, you are getting old. For those of you having trouble, I estimated this number is about 118. We started at 20. So it's 98, not 118. Oh, and those of you screaming at the computer pointing out my mistake, thank you. 98 over 6 is what? Now let's try a slightly less sucky number. 98 6 is, ooh, 16.3. 3 and out. As I said, trying to read the exact number off the graph sucks. We know it's 16, so I'm just going to squint and close my eyes to call it 16. Right. Now, the important thing is, since the rate of change or slope is higher than grant's pay is higher than C's, we know that grant makes more per hour. More money per hour. Grant's line is steeper than C's. Which is steeper, 20 or 16? 20. Right? So, just a reminder, recall that there are a few different types of slopes you have to remember. Positive slope The rate of change is positive. Since the dependent variable is increasing as the independent variable is increasing, it's going up. Negative slope. The rate of change is negative since the dependent variable is decreasing as the independent variable is increasing, or it's going down. And now I know independent, dependent, something sucks, but you gotta remember. Zero slope. Here the rate of change is zero because the dependent variable stays the same as the independent variable. Oh, sorry. Going through this, I'm giving you a chance to comprehend the missing words. The rate of change is positive since the dependent variable is increasing as the independent variable is increasing. Now, the rate of change is negative slope. The rate of change is negative since the dependent variable is decreasing as the independent variable is increasing. Now, zero slope. Here, the rate of change is zero because the independent variable stays the same as the independent variable increases or changes. Undefined slope. The slope of the vertical line is undefined. This is because the run is zero. Since the formula is rise over run, we would have to divide by zero. It's impossible to divide by zero, so the slope is undefined. Now, those are definitions you have to know. Now, I'm going to go back and show you how to graph these equations on the graphing calculator. So this is it, but I will show you how to use the graphing calculator if you remember, or if you want to. All right? So if you find this, go do the classwork. If you want to learn to use the graphing calculator, keep on paying attention. Now, here, can graphing calculator R. Notice I put in the two equations, Grant and Steve. Now to graph them, and just hit the graph button, and you're going to fuck up. Now, here you go to, go to Windows. Additionally, I want you to go start minus 10 to 10. X goes from minus 10 to plus 10. Y minimum goes minus 10 to plus 10. That should be your standard setting. Always go there. Now, if I'm going too fast, just pause. Tell me, you have to pause and think about it. But these should be your windows. However, when we graph it, notice there, back here, hours worked. X is our hours. We start at 0. All right, and we go to 10. Now the question is, what's our Y values? Well, you notice here from the graph, actually better look at the table. Table, like that. Come on, table. People are watching something. We're quickly getting up at 10. When X is 10, we're getting Y of like 180, 200. So set my windows 0, say 200. And I'm going to say go up 10. And there's Steve and Grant. And there we go. There's the two graphs drawn on our graphing calculator. Okay? And like I said, if you want to be able to use the graphing calculator, that's nice. I'll give you graph paper. I'm not going to ask for, I'm not going to make you do graphs like this. What I want you to be able to do is look at the table of values and read the numbers off. Save yourself time to calculate. All right? That's what I hope you can do. Okay? Now, that's it for me. Review this. Go do your classwork. I'll see you in class, all right? If you've got questions, shoot me an email. Or see me in class. Good luck. Good luck.